Good morning, respect to the lecturer and fellow classmates. Today, our group will be presenting our mini project entitled Utility Billing System using C programming. This project combines programming concept with business application to create a simple billing management system for utility companies such as electricity, water, and gas provider. So let's begin with our presentation.
Before we begin, let me introduce our group members who contribute to this project. Each member participated in different parts of the project, including system analysis, programming, documentation, testing, and presentation preparation. This is my friend Nick Moizidin, and the next person is me, which is Nick Rashidi. Okay, now let's move on to the introduction.
The main problem faced by many small organizations is the use of manual bookkeeping systems. This method often lead to human errors, slow data retrieval, and poor financial record management. So to solve this problem, we developed a console-based utility billing system using the C programming language. The objective of this project is to combine engineering programming skill with practical business operation by managing customer information, calculating monthly utility bills, and monitoring payment system efficiently.
Now, I will explain the technology aspect of our project. First, we use global parallel array to store customer information such as customer ID, customer name, units consumed, and payment status. Next, control loops, including for loops and do while loops, allow the program to repeatedly display the menu and process user input. We also use if-else statement to make decisions such as selecting the correct pricing tier and validating customer information. Finally, the program is divided into user-defined functions, making the code more organized, easier to debug, and easier to maintain.
So from the business perspective, this system improves data organization by linking each customer ID with customer information. The system also applies a tier pricing strategy where customers with higher usage pay higher charge. This reflects how real utility companies calculate bills while encouraging responsible resource consumption. In addition, the system generates financial reports showing customer usage, total bills, and payment information. Lastly, payment tracking helps the company monitor the paid, pending, and overdue accounts and improving cash flow management.
This slide shows the system flowchart. The flowchart illustrates the overall process of the system, beginning with user input, processing customer data, calculating bills, generating reports, updating payment status, and finally ending the program. It provides a clear overview of how information flows throughout the entire system.
So this flowchart explains the detailed logic of the application. It starts when the user select a menu option. Depending on the selected function, the system perform different tasks such as adding customer, viewing records, calculating bills, generating reports, or updating payment status. After completing each operation, the system returns to the main menu until the user chooses to the exit.
On this slide, we can see the beginning of our C program. First, we include the necessary header files such as stdio.h for input and output function and string.h for handling string operation. Next, we declare the function prototypes. These tell the compiler which function will be used later in the program, making the code more organized. Finally, we define the global variables and arrays that store customer information such as customer ID, customer name, unit consumed, and payment status. These variables are declared globally so every function can access the same data throughout the program.
So this slide shows the main menu function of our program. So the program starts by displaying the main menu using do a while loop. This loop keeps the program running until the user chooses the exit option. User can choose different functions such as adding customer, viewing records, calculating bills, generating reports, or updating the payment status. The switch or if-else statement then direct the program to the correct function based on the user selection. This creates a simple way and user friendly menu-driven system.
Okay, this slide explains the add customer function. The system asks the user to enter the customer ID, customer name, unit consumed, and payment status. Before saving the information, The program performs input validation to ensure the entered data is correct. If the input is correct, the customer information is stored in the arrays, and the program display a confirmation message. This function form the foundation of the entire system because all other features depend on the customer data and stored here.
So now we move to this slide. This slide shows the function that display all the customer records. The program is for loop to go through every store customer one by one. For each customer, the system display important information such as the customer ID, customer name, unit consumed, and payment status. This function allows user to quickly review all customer information without searching manually.
This slide contains the bill calculation function, which is one of the main features of our system. The user first enter a customer ID. The program searches for the matching customer record and calculates the monthly bill using a tiered pricing structure. Different unit range have different rates, so customers who consume more utilities will pay a higher amount. Finally, the calculated bill is displayed to the user. This calculation follows the same concept used by real utility companies.
So this slide explains the payment and report function. The program gathers all customer information together with the calculated bill amount and payment status. The reports provide a complete financial summary that helps user monitor customer payments. This function is useful for business management because it allows companies to identify customers who have paid, are pending payment, or have their overdue accounts.
On this slide, the program allows user to update a customer's payment status. The user enters the customer ID and selects a new payment status. The program first validates the customer ID and then updates the payment record if the customer exists. After the update is complete successfully, the system displays a confirmation message. This feature helps ensure that payment records may remain accurate and up to date.
So now we move to the final source code slide to demonstrate the program input validation. Whenever user enter an development option, incorrect payment status or customer ID that not exist, the system display an appropriate error message instead of crashing. This makes program more reliable, user-friendly, and secure. Overall, our source code follow the principle of modular programming, proper validation, and structured logic, making it easier to understand, maintain, and improve in the future.
Okay, this slide shows the first output of our program. The first screenshot displays the main menu which contains 6 available functions. The second screenshot demonstrates the customer registration process. Users enter customer details and once the information is validated, the system successfully stores the customer record.
So here the first output display all the customer records stored in the system, including customer ID, customer name, and unit consumed. So the second output is demonstrate the monthly bill calculation. So the system retrieve customer information and calculates the bill automatically based on the tier pricing structure.
This slide shows two additional system functions. The payment report summarizes customer information, units consumed, total bill, and payment status. The update payment status function allows user to modify payment records after customer make their payments. The system confirms every successful update.
So our program also includes input validations. If user enter an invalid option or payment status, the system display an error message and request correct input. Finally, when the exit option is selected, the programming terminates safely and display a closing message.
This slide presents the estimated IT financial budget for developing this project. The budget includes hardware requirements, software tools, development resource, documentation, and testing. Proper budgeting helps ensure that the project remains cost effective while meeting all development requirements.
This slide continues the financial budget details, showing the allocation of costs for different project components. The estimate budget demonstrates that this project can be developed with relatively low implementation costs while providing useful business functionality.
In conclusion, our project successfully achieved its objective. We developed a menu-driven utility billing system capable of managing customer records. calculating bills, generating reports, and updating payment status. The project demonstrates the importance of modular programming, input validation, and structured planning using flowcharts. Overall, the system reduces manual errors, improves efficiency, and supports better financial management.
In the future, this project can be expanded in several ways. First, customer information can be stored in a permanent database instead of temporary arrays. Second, a graphical user interface can be replaced the console-based interface to improve the user experience. And finally, cloud storage and online payment integration can make the system suitable for real commercial applications.
That concludes our presentation. Thank you very much for your time and attention. We hope our presentation has given you a clear understanding of our utility billing system project. We are now ready to answer all questions.